My name is Tim Carden. I'm an application specialist at Dynamic42, and I worked extensively on the intestine on-chip model and also the integration of real-time measurement sensors. The DynamicOrgan TEER-Sensor system was designed to continuously measure barrier dynamics in real time. The kit itself contains the Dynamic42 biochip with integrated TEER sensors, also the microfluidic accessories around the TEER measurement device, and if not purchased yet, the peristaltic pump system. Conventionally, barrier permeability in cellular tissues is assessed by measuring the permeation of a fluorescent tracer dye via a permeability assay or integrating chopstick electrodes into transvaal systems. Nevertheless, these methods to measure the barrier permeability, they are quite prone to low sensitivity and also due to electrode motion or cell invasiveness. With the TEER sensor system, we integrated electrodes at a fixed position without moving around in the chip. Furthermore, these electrodes are there to measure barrier integrity in real time over a long period of time during the experiment. And it's also possible to use the kit in a very easy plug-and-play manner, which is designed to be as user-friendly as possible. Basically, you can set up every kind of organ model of interest in our TEER integrated biochip platform. You can either decide to perfuse the chips with our peristaltic pump system or culture them under static conditions, everything in a cell culture incubator. Afterwards, the chips are then connected via their circuit board to our TEER measurement device. The TEER measurement device can measure TEER in 3 different biochips, and since each biochip includes 2 different cultivation cavities, you can measure up to 6 conditions in parallel at the same time. The TEER data is then transferred in real time via wireless transmission to an external computer. The TEER measurement device applies an alternating current through the organ model in a vertical manner inside of the biochip. The cellular resistance is then again measured after the alternating current went through the organ model and is then detected again by the measurement device. A higher TEER value means a higher barrier integrity inside of the model, whereas a lower value indicates also a decrease in the barrier function. There are several applications for the TEER sensor system, including disease modeling, drug compound testing, and also host microbiota co-culture. But there are definitely more applications where you really want to study barrier dynamics in real time. We validated the functionality of the TEER sensor system by using our intestine on-chip model. And in the intestine on-chip model, we induced barrier disruption with a chemical agent, and afterwards we were able to recover this barrier breakdown by removing the medium and applying fresh medium that the cells do recover and form again a very tight and intact barrier, which was also reflected in the higher TEER levels. The applications are not only limited to intestinal tissue, but you could also imagine to integrate tissues from other organs from the human body, for example from the lung or the liver.